Okay, so imagine you're working on this huge project with multiple modules. There are separate teams in place independently working on each module. Now, if it's a monolithic front end, meaning there's a single code base that maintains everything, it will become a challenge pretty quickly to manage this application. The time to build significantly increases because everyone's code is inside this one app. The possibility of getting merge conflicts also significantly increases because, again, everyone's contributing to this one single code base. Even getting new engineers onboarded to this monolith app becomes challenging because it can get overwhelming for an individual to go through all of this code. Again, I have like 10 more reasons why a monolithic architecture could create problems for a large scale project, but I'm sure you get the idea. So, how do we solve this problem? This is a pretty significant problem. It's actually pretty simple, to be honest. Teams can work on different projects independently without worrying about all the challenges that I mentioned a minute ago, and somehow eventually piece all of them together. It's basically this micro front-end pattern which has been out there for a while but is picking up lately because there's just too many advantages. You now don't have to worry about longer build/deployment times because teams can now independently deploy their own micro frontends, updating specific sections of the app and not the entire thing. This also means each app can have their own CI/CD pipeline. The chances of getting merge conflicts also reduces significantly. And I also forgot to mention, when you have a single monolithic architecture, you are limited by a single tech stack and you can't really experiment and be flexible inside the team if you want to try out like new libraries or new modules. This happens in case of a monolithic app, but in case of micro frontends, that's not the case. You can use different frameworks if you want, because on paper, the final product that gets shipped is essentially JavaScript. So it doesn't really matter what kind of framework or libraries you use. At the end of the day, if it's JavaScript, it doesn't really matter. Now, there are challenges though when it comes to micro frontends because sharing things between multiple apps is kind of tricky. I mean, most of the times these micro frontends will be built out of a single framework, but the only thing that would be different between these apps would be third-party libraries. If you want to use a different state manager for application 1 as compared to the other applications, you can do that very easily with this micro frontend kind of an architecture. With this kind of parallel operations, teams in general will produce better output without bumping into each other. Now, obviously, there are some challenges with this architecture as well. It's not all sunshine and rainbows when it comes to micro frontends. And I feel that some of y'all might even consider this as an overkill once you start facing complexities. And to a certain extent, I do agree, but I'll let you be the judge of that. What I'll do is I'll create a basic implementation in React with Vite, and I'll build on top of that and we'll see how it goes. So I'm going to take a monorepo approach here, meaning there'll be only one GitHub repository and multiple React projects in it. Again, it's not an absolute necessity to be honest, but since I am going to use PNPM, and since in a real world scenario, these repositories will have common modules between each other, it makes more sense to go with PNPM. PNPM handles packages more efficiently if they are being used in multiple projects, which brings down the disk space utilization and also speeds up the installation process. So do install PNPM in your system if you haven't already. You can install it in your system if you already have npm by typing in npm install -g pnpm. So just do this and you should be good. I already have it in my system, so I don't really need to do this, but yeah. Again, it's not a necessity. If you want to go forward with regular npm, that's perfectly fine. So what I'll do is I'll first initialize our monorepo. So let me create a directory for our project. I'll call it micro frontend demo. And inside, I will initialize our project. Let me also open this inside a different VS Code instance. Now I'll create two directories for two different apps. We'll have a host app and a remote app. I'll come back to why I'm calling this a host and a remote, but for now, what I'll do is I'll create a packages directory, and inside packages, I'll create host and I'll create remote. Now, the reason why I have named these two folders as host and remote is because these terms host and remote in the context of micro frontends and even module federation describe the relationship and interaction between two applications. So the host app is like a main application which acts as the entry point for the user. It integrates components from remote applications as part of its functionality, effectively hosting these micro frontends. In real world terms, the host app could be something like an e-commerce platform's main website that imports functionality like the cart section, the product recommendation section as remote micro frontends. Which brings me to the remote app, which is a standalone application or a module that exposes certain components, functionality, or services. These modules are dynamically loaded by the host app during runtime. So if you go to the same example, the cart system or even the product search module, the search bar that lets you search for a specific product inside the e-commerce app, these two separate components can be implemented as a remote app, and then the host app will pull them as and when needed. So that is the key here. The remote app is a standalone, independent, regular React app. You can expose certain parts of it or the entire root level component as a whole. It's up to you, to be honest. But most commonly, you'll see folks sharing certain components or services from this remote app. So what I'll do is I'll actually create these React apps. So inside packages, I'll first go inside the host directory and let me create a React app. So npm create, and I'll also install the dependencies. We also need one extra library in this project, which is basically going to help us with module federation. And the name of the package is Vite plugin federation. And I'll install a very specific version of this package. The reason why I'm doing that is because I actually tried this out with the most latest version, which is 1.3.7. It got released like a couple of days ago, and for some reason there are a lot of bugs with the build, the production bundle that gets created for the remote app. So 1.3.6 worked fine for me before, which is why I am going to stick with 1.3.6. Once 1.3.7 is stable, maybe you can go forward and install that version. But for now, we'll stick to 1.3.6. Once this is done, I also have to update the Vite config file for this app. So first, let me take you through this host application. It's a simple React app. Inside the Vite config file, I'm going to replace this default config with a config that I've already built. I'll come to that in a second. I'll go through each and every line inside this config. But for now, I'll just replace it over here. And now let me set up the remote app as well. So I'll create a separate terminal because anyway we'll need two different terminals to serve both of these applications. So I'll do it right away. Let me go inside the packages folder, remote app, and we can basically run the same set of commands that we ran for the host app. So first I'll set up a React app, then I'll install all the dependencies. And finally, I will install Vite plugin federation. Just like we replace the config for the host app, I'll do the same for the remote app. There is a slight change when it comes to the configuration. So I will take you through that as well. Let me just copy the config. All right. So now that we have both the configs here, let's go through each and every line one by one. Let me bring both of these side by side. So we have the host config here on the left, the remote config on the right. We have this name key, which is basically the name of this host app and the remote app. And you have this shared key, which is again common between both of these configs. It's essentially used to share libraries between the host and the remote app to avoid duplication. Now coming to the keys that are not common between these two configs, the first one is the file name key inside the remote app. This file name key points to the file where the module federation manifest will be created. This manifest file is basically the entry point for the host app to consume modules from this remote app. I'll come to that in a minute. This needs a little bit of elaboration, so be with me. The exposes key specifies what this remote app makes available for other apps. So in this case, I have this button component that I'm going to expose from this remote app, which can be used inside the host app. So this button here, the name of the key is the alias, of the exported module, which in this case is the button component. And this is the actual path of that button component. So we will create a button component inside this path, inside our source directory of the remote app. So I'll do that in a minute. In the host apps config, we have this remotes key, which just specifies the remote apps it will consume. So in case of the remote config, we had an exposes key that exposed a certain set of components and modules from this remote app. And in case of host app, we have the remotes key that specifies the remote apps it will consume. This is again the alias that we will use when we import the remote module. And this is the actual paths of the main manifest file. So this remote entry file is going to be served on localhost 5001. This is the specific path that I have chosen. So this remote app will be accessible when we serve it on this URL. Finally, we also have these build configurations. The module preload configuration controls how Vite handles preloading of modules before they are needed. This actually improves the page performance by reducing the time spent on fetching dependent modules. So if I set it to true, it ensures that the browser begins downloading these dependencies as soon as possible, which potentially reduces delays when the dependencies are needed. But if it's set to false, there will be no preloading of modules. Now I have kept it to false here because setting it to true brings in a few additional challenges, which doesn't really make sense for this video. But ideally, you should try to preload modules, maybe not all of them, but definitely the critical ones. You have this option called resolve dependencies, which is just a regular function that lets you customize which dependencies to preload based on your own criteria. So you can use that in your own application. Ideally, you should not set this to false, but for this particular example, I'll do that. Then we have this target key that specifies the JavaScript version for modern browsers. The reason why we are doing this is because micro frontends typically target modern browsers that can natively handle dynamic imports and ES modules. All these are like modern JavaScript features which are supported by modern browsers. Using an older JavaScript version like 2015 outputs ES6 compatible JavaScript for older browsers, meaning there will be some unnecessary transpilation or like there'll be polyfills created just so that it works on older pre-ES6 browsers. We know this is a modern architecture, hence we are going to use ES next, which will reduce the bundle size and even the build time. Then you have this minify key that disables minification, making the output easier to debug. I can very well set this to true because we won't be looking at the final build in this tutorial. And to be honest, it should be set to true, again to reduce the asset size and improve the load time. But if you want to debug something in the final build, you should set it to true. Then we have this final config, which is CSS code split. It basically combines all the CSS into a single file rather than splitting it. Again, there are a lot of other build settings that you can use, but let's not overburden ourselves. Let's try to keep this simple for now. Before going to the remote entry file that we saw here, let's quickly skim through the React bit. So I will close both of these files and let's start with the remote app. So inside this remote app, I'm going to create a button component inside a components folder. I'll be using JSX for now. I don't really need TypeScript for this example. It's going to be pretty straightforward. So let's not confuse ourselves with TypeScript. This button component is again super simple. All I have here is a simple state, and I'm displaying this state over here inside a button component. The on-click handler of this button component basically increments this state by 1. That is this button component. Let me also add in a few styles inside this CSS file. And now let's go to the host app. So inside the host app, we will consume this button component. So at the top here, I'll first import this button, and somewhere at the bottom, maybe right next to this paragraph, I will use this button component. So if you look at the import statement here, I'm referring to the alias that was configured inside this Vite config, the alias for the remote app. And inside this remote app, you will have the button component. That is what I'm trying to access here. That is what I'm trying to import here from the remote app. So I have the button component inside the app file. Now I want to run this and see whether it works or not. This is where it starts to get a little complicated. For starters, what you'd assume is that we'll run both the apps in dev mode. So let's do that. Let's actually try that out. I'll open up the terminal again, and we have the remote app here, the host app here. Let me bring this up. And inside the host app, let me run pnpm run dev. I'll do the same thing inside the remote app. Actually, before doing that, I don't want these random ports. I want a specific port. So what I'll do is I'll go inside the package.json file for both of these projects. This is the host app. So I'm going to fix the port for dev mode. In case of the host app, it's going to be 5000. And in case of remote, it will be set to 5001. Let me just replace the remote dev command as well. And I'll say both of these. Let's again run npm run dev. pnpm run dev. And you'll see that we have both of our apps being served on localhost 5000 and 5001. If I go to localhost 5000 and let me open up the console, you'll see that we get an error here saying that it failed to fetch the dynamically imported module. If I go inside the network tab and let's just reload this application once, you'll see that we are trying to access, at least this host app is trying to access this remote entry file, but it's getting a 404 error. It's not able to access this remote entry file for some reason. So how do we get this remote entry file? The solution here is to build the remote app. I need a production bundle of that remote app. I can't really run the remote app in dev mode, unfortunately. So if I go to Vite plugin federations doc, you can see here that only the host side supports dev mode. The remote side requires the remote entry.js file, the manifest file, which will have all the components from the remote app. The remote side will require this remote entry.js package, and this can only be generated with the help of Vite build. Vite's dev mode is bundleless, meaning there is no production bundle that's being referred when you run the Vite app in dev mode. So we have to somehow build the remote app first and then serve it so that the host app is able to access it. So this is a challenge that we're facing right now. So what I can do is I can follow the suggestion that they have mentioned here. So running Vite build with this watch flag, this will basically rebuild the remote app anytime I make a change. But again, this is just half of the solution. I want a hot reload functionality or something similar that resembles to hot reload. So anytime I make a change on the remote side, even the host app should reflect that change. But here, it won't do that. It will only rebuild the remote app, but it's not going to reflect the change inside the host app. So I just went through the issues section of this GitHub repository to find a way to get through this. And I did find a workaround for it. So firstly, we can use the same thing that they have suggested, Vite build with watch flag. So anytime there's an update in the remote app, there will be a new bundle created for it. In conjunction to this, we can also serve the bundle on port 5001 using Vite preview so that the host app can access the remote entry file. So I've combined both of the steps in a build command, and it looks something like this. I'm going to paste that inside the remote apps build command because we don't really need this in the host app. Host app works perfectly fine in dev mode. So I'll save this, and you can see that this is the new command wherein we first build the remote app with the watch flag, and then we serve this bundle using Vite preview on port 5001. But this unfortunately will not work on my Windows system. This could work in a Mac system, but for some reason, the operator, the ampersand operator works differently in Windows systems. So what I'll do is I'll quickly install a third-party library called concurrently. This library will let me concurrently run these two commands. So I'll install it in the remote app concurrently. And since it's supposed to be a dev dependency, I'll save it as one. Let me clear this, and I'll just update the build command now with this new syntax using concurrently. Now I will run build instead of dev in case of the remote app. So pnpm run build. If I go inside the browser and refresh this, let me again build this app. Maybe there was some issue here. Let me reload this. And you see that we get our React app. We also have this hello world button, which is the button that we are getting from the remote application and not this host application. Inside button.jsx, you see that we have this hello world. So essentially we are using a component from the remote app inside this host app. We are actually implementing a micro front-end strategy here, and it is working as expected. Now, even with this implementation, for some reason, I was not able to get an automatic reload on changes in the project. When I say in the project, I mean the remote app. So anytime I try to make changes inside this button component, which is part of the remote app, say for instance, I add one, and I go back to this post app, you'll see that it's not reflecting the new change. Only when I reload this, you'll find this new text here inside the button. So it's not giving us that hot module reload kind of a functionality. And I still want that because that is again a critical part of dev experience. So I went through one of the issue threads in the GitHub repository, and someone had shared a simple plugin that sends a reload message from the remote end when there's a build triggered, and a listener plugin on the host application's end that's listening for this reload message. So basically, anytime there's a build triggered on the remote end, there will be a message sent, which is being listened to inside the host application's config, and it's going to reload the host application anytime that happens. So it's again a simple to and fro message communication between both of these apps. So I'll just copy both of these plugins in our app. So inside the remote config, I will paste this plugin, and inside the host config, I will again paste a similar plugin. I'll paste a link to this GitHub issue thread in the description. You can go through it, but I will have to reload both of these apps since I've made changes to the config. Let me also reload this. Let's run npm build. Let's go back to the browser. Now, let's see if this works. Let's see if the hot module reload feature, which is not exactly hot module reload, but the simulation of that feature, let's see whether it works. So what I'll do is I'll go back to the button component and I'll remove this one. Let me save this. And if I go back to the browser, you see that it now automatically reflects it without me trying to reload this application. So again, this is not technically hot module reload. We are serving the actual production bundle. So this would for sure take a hit when the app grows in size, but at least you have something to work with. So now we have two React apps using module federation running a micro frontend setup. But the obvious next question is, what about state? Say for instance, I want to update state from one micro frontend and it should reflect in the other. How will these two apps communicate? These two apps obviously operate in like isolated spaces. So is that even possible? Obviously it's possible, and it's not even that difficult, to be very honest. So let's take a simple example. What I'll do is I'll try to share state from the remote app to the host app. I'll create a simple React context provider that exposes the same count state. So let me actually create a context provider inside the remote app first. I'll just create a new file called my context, and inside here, I'll just create a simple React context. So what you have here is just simple use state. Again, very similar to what we had inside this button. It is set to 0 by default, and you have an increment function. This increment function and this count is being exposed as part of this provider, and you can use it pretty much throughout your entire application. I also have a hook that basically exposes the values from this context. So you don't really have to use the use context hook everywhere. You can use this one custom hook throughout your application. So now I need to expose this provider inside the module federation config. So I'll go back to remote, and over here, I am going to expose the provider as well. I'll call it my provider, and the path to it will be source my context. Inside the host app, we'll wrap this provider wherever needed. Ideally, you should make sure that you only wrap this around components that will use this state, because this could potentially trigger unnecessary re-renders. But for this example, I'll just wrap it around the entire host app. It doesn't really matter for this simple example. So in the host app, I will go inside main.jsx and I'll wrap the entire thing over here. And this my provider is not coming from this path. Instead, it's going to come from remote app slash my provider. Again, very similar to what we did inside the app.jsx file. It's part of remote app slash button. This time we are going to use remote app slash provider, my provider. Now we have the main provider wrapped around the app component. Inside the app component, let's use the hook. So what I'll do is I'll import the use shared state hook that I have exposed from the remote app. This thing right here. Let me use it inside app.jsx. Use shared state. Again, not from this path, but from remote app my context. I'll use count and increment from use shared state. And let me create one more button here somewhere at the top that pretty much does the same thing as our original button, but it will let me comment this out. I don't really need it. Let's use this over here, and on click of this button, I'll simply run the increment function. Let me comment this out for now, and I'll save this. If I go back inside the browser, for some reason there is an error here. Maybe I'll have to rebuild my application. So let's do that. Let me clear this and I'll run the host app as well, just to be safe. Okay, let's go back to the browser again. And I still can't find the remote module my context. Actually, this is supposed to be my provider and not my context. Now you'll see that we have our application here, and we also have this extra button. So this button is using the use shared state hook that is exposed from the remote app. If I try to increment this, it works as expected, but we want to actually look at how the state is being shared between these two components. So anytime I make a change inside this button, which is part of the host component, host application, it should also reflect some kind of a change inside this remote apps button. And it should also work the other way around. So if I click on this hello world button, it should reflect change inside this button, which is part of the host app. So this is what I meant by sharing state between two applications, two micro frontends. So how do we achieve that? It's again pretty straightforward. Let's go back to our application. Inside the button component, which is part of the remote app, instead of using this, I will use shared state hook right away. So since this hook is native to the remote app, we don't really have to refer to the remote app slash my context slash my provider. This is part of the remote app, so we can directly use it and update state as and when needed. And whatever state that gets updated here, it should also reflect the same update inside the host app. So I'll again use count and increment from this hook, and instead of state I'll use count, and instead of this I will replace it with increment. So now this button as well as the button inside the app.jsx file, which is part of the host application, both of these buttons use the same hook which is pointing to the same state. So the increment function is going to increment the same state, meaning anytime I make changes from the host app, it should reflect inside that remote button, the button over here. And anytime I make a change inside this remote button, it should reflect inside this button as well, which is part of the host application. If this works, meaning if I click on any one of these buttons and both the values change, this means that we have successfully shared state between two micro frontends. So let's do that. Let's try it out. I'll click on count 1 and you see that it gets reflected in both of these buttons. If I do the same here, it also again updates the button inside the host application. So we are successfully sharing state between these two micro frontends. So yeah. Also one more thing, not sure if I've already mentioned this before, but the host app can also expose components just like the remote app. It's the same Vite config, but then I'll also have to build the host app and then serve it, just like we did with the remote app, because it will also have the remote entry file, the one that gets generated after we build the application using Vite build. So you'll have to take care of that as well. But yeah, host can also expose components and services just like we did with the remote app. If you're using any other state managers like Redux or Zustand or something similar, you can follow the same set of steps. Just make sure to add these dependencies inside the shared array. So inside the config, you have this shared property, right? You can just pass in Zustand or Redux inside this shared array so that it doesn't get duplicated between both of the micro frontends. So yeah, I'll just stop here for now because I'm assuming that folks who are watching this video have minimal knowledge on module federation, and this would turn out to be too much information if I go any further. So I'd suggest you to go and play around with this yourself and see if you can build something on your own. Let me know if you want any advanced implementation on top of this example, and I'll see if I can come up with a video on that. Also, do subscribe to the channel if you're new here, and I'll see you in the next one.